So today we are going to discuss the Laue's theory of X-ray diffraction. So due to the drawbacks of Bragg's law, so the important drawback was that it does not incorporate the interaction of X-ray with the atoms. It only uh, the X-ray is only diffract or reflect from the atomic planes. So we are considering here that these X-rays are scattered by these individual atoms A and B. So the unit vector for that gives the direction for this ray 1 is n1 for this incident ray, and for the scattered ray your unit vector is n2. This unit vector n1 and n2 gives the direction. So now this 2 theta is the scattering angle between this incident ray and that scattered ray. So now let us draw a perpendicular from B to M and A to L. So now we have to since these X-ray are getting scattered from this, and they are they are interfering constructively, and the maxima is formed on the pattern. So therefore, to get the maxima, what is the condition for the diffraction? That path difference is equal to n lambda. This is the condition for the constructive interference for the diffraction pattern. So now we have to find out the path difference here. So how we will find out the path? So ray from here to here is equal, and from here to here is equal. So now path difference will be this. Suppose this is delta 2, path difference 1, this is delta 1. So by subtracting this and this, we will get the path difference. So path difference from here will be delta will be, that is from subtracting from this AM or LB, AM minus LB. So this will be the path difference. Subtracting by this, there will be a small path difference. So this is equation number 1. So now our aim will be to find out the AM and LB. So now we will consider this triangle, this ABL, LLBA. So from right angle triangle, that is LBA. So this is your perpendicular, this will be your base, and this will be your hypotenuse. So now we have to find this. So your cos phi 1 will be, because we are considering this phi 1, this will be B upon H, that is LB upon, this is AB. AB is the distance from this atom A to this atom B. So this will be, so here I am taking a magnitude, this will be, so this will be LB will be AB cos phi 1. So this will be AB is R magnitude, this is cos phi 1. So also you can say this as, this is LB. So now here this is you can also say that this is R vector. You can also say write like this into n1 unit vector, because here this phi 1 is the angle of inclination between this n1 and this R और n1 के बीच में, n1 यूनिट वेक्टर के बीच में एंगल phi 1 है. So your LV is equal to R dot N1 का dot product. So this is equation number 2. So now we have to find AM. So similarly, from triangle AMB, triangle AMV. So here this is a base, this is perpendicular, this is hypotenuse. So therefore cos phi 2, here angle is phi 2. This angle is angle of inclination between R and this R and N2. This R and N2 के बीच में inclination angle है. This will be AM upon AB. So therefore AM will be AB cos phi 2. So you can say that this is what is AB? AB is equal to R cos phi 2. So it can be written also like the dot product. This will be R vector dot N2 unit vector. This is AM. Equation number 3. So put the value of that is put the value of this to equation 2 and 3 into 1 by equation 1, 2 and 3. We got that is part difference is equal to AM is your R dot N2 minus R dot N1. This is simple, and this will be R common, this will be N dot N2 minus N1. So this is delta. You can describe this by another vector. This is R dot capital N vector, where capital N vector is the difference of these two unit vectors. This is equation number 4. This is equation number 5. So here I am describing that this capital N vector is the difference of these two unit vector, N2 unit vector minus N1 unit vector. So also by using the property of vectors, I can write that N1 and N dot N is equal to N square. So N square will be, if I put the value of this N, this will be N2 minus N unit vector. This will be N2 minus N1. So if you solve this, this will be N2 dot N2 plus N1 dot N1 minus 2 N2 dot N1. So since this will be N2 square, this will be 1, because the magnitude of this will be 1. Magnitude of unit vector is always 1. This also be 1 minus 2. So this is dot product, so their magnitude will be 1, and angle between them is cos 2 theta. Here angle between them, this is N1, this is N2, the angle between them is 2 theta. Therefore this will be 2 cos 2 theta. So this will be 2 minus 2 cos 2 theta. So if I put the value of this cos 2 theta, so the formula for this is 1 minus 2 sine square theta. So this will be, if I solve this, this will be 4 sine square theta. So this will be n square. So n will be, if you take the under root, this will be 2 sine theta. This is the value of n. So now we have derived that n is equal to 2 sine theta. So this can also be described by using your diagram, that this particular diagram. So I am considering that, let us discuss. This is the incident direction of this n1 unit vector, and this is your scattered wave X-ray. So this is your reflecting plane. So what is the angle? This is 2 theta. So so what we have discussed, that this n2 minus n1, so this is n1, this is n2. So according by using the vector laws, a vector diagram, so this, what this will be, this will be n2 minus n1. So this will be the n2 minus n1, and this is equal to n vector. So by using the vector law, this is n1 and vector, this is n2. So this vector will be n2 minus n1 by using the vector diagrams. And since if you, this is whole, this is n, so if you consider this half, so if this is whole n and this will be, so then this half will be n by 2 if you take the magnitude, n by 2. This is theta, this is r, this is n. So now this is p into h. If you find out the sine theta from this diagram, sine theta will be p, this will be p will be n upon 2, and h, if you taking the magnitude, this will be 1, this will be 1. So therefore, and from here, this is 2 sine theta. So we have also derived this n is equal to 2 sine theta from this vector diagram. So now we have found out the path difference. So now we will find out the phase difference. Then the phase difference, formula for the phase difference is equal to 2 pi lambda into path difference. So phase difference phi will be, difference denoted by phi, this will be 2 pi lambda into delta. What is delta? Delta is equal to r dot n. This is the phase difference we have found out. So this is the phase difference. So now we have these waves are getting interfered constructively. So we are getting a diffraction pattern for the maxima. So for constructive interference, the condition for that phase difference for constructive difference, this will be 2 pi into integer. So now here I am taking a particular direction r. So now if you think in case of crystal, there are three crystallographic axes A, B and C. So if this are coincided on all three axes, that is A, B and C crystallographic axis. So therefore in terms of crystallographic axis, so that is your, by using this condition, your phase difference is, where R in case of A primitives, this will be A dot n, this will be 2 pi h dash. So since these crystallographic axis, that is A, B, C, they have particular Miller indices H, K and L. So therefore this will be 2 pi h, where h dash is for particular Miller indices index. This will be 2 pi n h. So this is for describing particular Miller indices. So this will be n into h, where n is greater than equal to 1. For second crystallographic axis, primitives will be B, this will be n. So Miller indices for this B will be L. So this will be sorry h, this will be K, HKL, this will be K dash, this will be 2 pi n K, and this will be 2 pi L upon lambda. This will be C third primitive, this will be 2 pi into L dash, this will be 2 pi into n into L. So now if you solve these equations, so 2 pi will be cancelled and pi will be here. So by solving these equation, pi will be cancelled. So this will be A dot n, by solving pi will be, and pi lambda will be this side, this will be n h lambda, this will be B dot n K lambda, C dot n will be n L lambda. So now if you particularly solve for this side of these equations, so now this is A, if you take the dot product, this will be A n, this will be cos theta. For in this case, since these are primitives for the crystallographic axis, so for this there will be interfacial angles. For this will be alpha, this will be beta, there will be gamma, there will be the cos alpha. If you solve this, and this will be n h lambda, this will be B n cos beta, this will be n h n K lambda, therefore this will be C n cos, this will be here in this case angle will be gamma, this will be n L lambda. So these are the equations. So now we will put the value of this n into these equations. For this equation number 13, we will put the value of n, which is n is equal to 2 sine theta. Now put the value of n into these equations. Now by putting the values of n into the equation number 13, we will get 2a sine theta cos alpha and h lambda, and by putting this value we will get these equations, and these equations are known as Laue's equations of X-ray diffraction. So these equations have overcome the major drawback of that Bragg's law, which is that it does not give the interaction of X-ray with the atoms of your crystal. So these are the Law's equation.